Okay, so this is the only math that we're doing this whole chapter, and it has to do with measuring atmospheric pressure and measuring different types of pressure. Okay, so a barometer is pictured here, and it's also in your note packet, is what we use to measure atmospheric pressure. This was the first kind of barometer that's ever been made. Barometers today are not like this necessarily. I have some in the back room. I might pull one out for you. The SI unit for pressure is a Pascal, which is PA for the representation of that. It represents a very small amount of pressure, so we don't actually use pascals all that often. For this barometer pictured here, there's a tube, and then in this whole thing is mercury, the element mercury, which is one of two liquids on the periodic table. It's liquid metal, okay? And so there's an empty space, the vacuum area, so there's no particles in there, inside this tube. And then the atmospheric pressure will press down on the mercury that's in the bowl at the bottom, and when it presses down, then it creates a force to make the mercury rise in the tube. And so then by how much the mercury rises in the tube, we can measure that, and then we have mm for millimeters of mercury as one of our units. Okay, so this is important for chapter 14, what we're doing today, but it's just a little precursor into that. So we have many different types of units for pressure. We could have mmHg, which is millimeters of mercury. We could have pascals for PA. We could have kilopascals, which is kPa. And we have ATM, which is standard atmosphere. You might hear other types of pressure, gas pressure, like in your tires. I know it's like PSI, pounds per square inch. But these are units of pressure that are with the metric system that we're going to use in chemistry class. It's important to see that 1 atmosphere is equal to 760 millimeters of mercury, which is equal to 101.3 kPa. It doesn't have to go in that order, because this is also saying, since they're all equal to each other, that 101.3 kilopascals is also equal to 1 atmosphere. Or 760 millimeters of mercury is equal to 101.3 kPa. Okay? One other thing to note, I might ask for it, I don't remember at this second in time, but to get between pascals and kilopascals, does anybody know, like if you have a gram versus a kilogram, how many grams are in 1 kilogram? How many? 1,000. Yeah. So you might need to know that. So I'd write this down somewhere, that there are 1,000 pascals equal to 1 kilopascal. Because if the question ever asks you for pascals, we can get to kilopascals using these information down here, but then we're going to have to convert it to pascals before we're done. Okay? So we have two examples, or it's one example, but we're going to do 2 calculations, and then we're going to practice this in the assignment packet. Okay? Ready to go? Nobody said no, so. We have a pressure gauge recorded at a pressure of 450 kilopascals. We want to convert this measurement to atmospheres and to millimeters of mercury. Okay? So we're going to do it 2 separate ways, just to show the ways that you can calculate this stuff. Okay? So I'm going to just put a 1 for the first calculation. So we want to go, we're starting with kPa, and we want to turn it into atmospheres, which is ATM. Okay? So we're going to set this up kind of like we've been doing with our mole map, with our dimensional analysis, but we're not actually, it's just so that we can convert the units correctly. Okay? No mole map needed for these problems. So I'm going to put my beginning number over 1. So 450 kPa over 1. And then looking back at what we had the 1 atmosphere is equal to 760 mmHg, which is equal to 101.3 kPa. I'm going to use these numbers to cancel out what I'm given and be left with what I want, right? Just like moles 1 over moles half kind of thing. So pressure 1 over pressure half. So for the first calculation, we want to have atmospheres. So what should go on top? It's 1 on top. So if I want atmospheres, what's the number that's going to go on top? 1, because 1 atmosphere is in our conversion. Okay? On the bottom, we have to cancel KPA. So what number from up above will cancel KPA? The 101.3 KPA. So by setting it up like that, the KPAs cancel out. We're left with ATM, which is atmospheres, which is what we want. So now it's just time to solve. So if it's one on top, one on bottom, we're just going to divide the two, right? So what do you get when you divide the two? 4.44? Okay. Atmospheres. Somebody else confirm it?
Yep.
Awesome. All right. Significant figures, because we always got to do that. Is this 2 or 3 sig figs? 2. There's no decimal place. It's a trick problem. So really, our answer should just be 4.4 ATM. Not too bad, right? Okay, now let's do number 2. So this is going to be a little wonky, but that's okay. Okay, so for number 2, we have KPA still. We're starting with KPA. But this time, we want millimeters of mercury. And so that's going to be our mmHg. That's what that stands for. Okay? So I'm still going to start with my 450 KPA over 1. But this time, in my second parenthesis, is the bottom still going to be the same? Yes, because I still have to cancel KPA, so I have to use the 101.3 to cancel that out. So the bottom will stay the same. But on top this time, what do we put? The 760 mmHg. We're not going to even touch the atmospheres this time, and that's okay. So by doing that, KPA cancels out. So now we're going to have to take the 450 times 760 and then divide by 101.3. What is it? 3,376. Okay. And then making that 3 sig figs, I'm going to cut off after the 7, so it's going to be 3. Oh wait, no, I have to make it 2 sig figs, don't I? Sorry, just kidding. So 3, 4, and then spot fill 2 more zeros. So 3400 millimeters of mercury. Not too bad, right?
Yeah.
Hopefully not. So in our packet, looking at our packet on page 2 of our homework packet, our assignment packet, we can do 8 through 12 with this information. Okay? So we're going to do numbers 8 through 12 using our conversions from our notes, and that's it.